Hey, welcome to Get Ready for Calculus. This is Skill 8, Conjugate Radicals. We're going to rationalize some denominators, do some other things here. Perhaps something that maybe you're like surprised to see, but it's going to help us, especially at the very beginning of calculus. Whenever we are working with limits, it's going to help us solve some limit questions. So let's just do a basic reminder of how to conjugate this radical. We don't want to divide by a radical. That's not really the issue we have in calculus. We're going to conjugate for other reasons, but we're going to multiply the top and the bottom by that denominator, except we change the sign of the radical piece. So 4 minus negative 3, 4 minus negative 3. So now on top, we're going to multiply that 1 through, which doesn't change anything. But on the bottom, you need to FOIL. And I say you need to FOIL because especially on top, whenever you have two binomials multiplied, you have to FOIL. But really on the bottom, what happens is that since we're multiplying by the conjugate, the outer and the inner will always cancel out. So you really only have to multiply the first, 4 times 4, and the last. Square root of 3 times square root of 3 is 3 with a negative sign on it. So this becomes 4 minus the square root of 3 all over 13. All right. And let's take a look at the next one. Simplify this. Okay, so again, we're going to go ahead and rationalize that denominator, multiply the top and the bottom by square root of x. We're going to worry about that 2 quite yet. So on the top, okay, now square root of x squared plus 2 times square root of x. Let's just think about something for a second. If I had square root of 3 times square root of 2, you could say that's square root of 6. If I had square root of 3 plus x times square root of 2, you could say that's square root of 6 plus 2x. You could distribute it. So we're going to do that here on our problem. We're going to say that's square root of x to the third plus 2x. Okay? Now, all of that is over square root of x times x is x, and then we have a plus 2 over here on the side. Now we want to get a common denominator of x. The 2 does not have that denominator. So we're going to multiply that 2 with an extra x and do that. Now that's really about all we can do here. There's kind of a mess. There's really nothing else to do with this, so we're going to leave it alone. All right. Even if you factored in this x back out of here, you just end up back where we were. Nothing would really cancel out on the bottom. I suppose you could factor out an x to the 1/2 out of everything. I'm just not sure that that's really very useful for us. All right, here we have another denominator that we need to conjugate. Square root of x minus 1, we're going to multiply by square root of x with a plus 1. Doesn't matter if you're changing the sign of the first or second term out of the binomial, you're going to get the same result. Now on the top, here we have a kind of a weird distributive property, right? So we're going to have to say square root of x times square root of x plus 1. So that gives me an x squared plus x inside there. And then a 1 times all that gives me just a square root of x plus 1. And on the bottom, remember whenever you're multiplying your conjugates together, you only have to do the first and the last. Square root of x times square root of x is x. Negative 1 times 1 is minus 1. And this is another one where we're just going to kind of leave it like that. Could we factor a square root of x out of that first one? Sure we could. We just end up back where we started, so nothing really is going to help us there. All right, and now let's look at this last one. Really kind of a weird question here. Perhaps I noticed right from the beginning I can change that to an x, square root of x squared. So let's see, square root of x squared plus 7 over the square root of x squared plus 7 plus x. We're going to conjugate by saying square root of x squared plus 7 minus x. Square root of x squared plus 7 minus x. All right, now on the top, we have another kind of weird distributive property here. We need to take that and that together. So that x squared plus 7 times x squared plus 7, both square roots, becomes a regular x squared plus 7. Then that negative x times all of that, I'm just going to put it in front. I'm not going to put it inside of it. And let's see what happens here. And on the bottom, since they're conjugates, we only have to multiply the first and the last together. You don't have to do a full FOIL. So the square roots of x squared plus 7 cancel out to x squared plus 7, and then we get a minus x squared. Okay, just a little bit of cleaning up we can do here. We see on the bottom we have an x squared and a minus x squared. Those will cancel out. So we have an x squared. Maybe we'll put the x term next, even though it has that weird radical with it. And then the plus 7 at the end, all over 7. So kind of a mess, but I'm not so worried about where we're ending up on these and how simplified they are, as much as I am the process of working with conjugates and rationalizing denominators. That skill is going to be useful for you, especially starting calculus out. All right, let's finish with an AI-generated math joke. Tell me a math joke about roots. Let's say square roots. Let's be a little more specific and see what AI can come up with for this. Here we go. Why did the square root of 9 become friends with the square root of 4? Because they had a lot in common and could always find the root of the problem together. Oh, okay. Heartwarming, perhaps. I don't know. There you go. So that's skill 8. This is Get Ready for Calculus. Pythagorean.com if you need more resources. Good luck getting ready for calculus.